From part 1 of the lesson, we know that to define a function, we need to know the rule, the domain, and the range. How do we determine the domain of a given rules? First, we can look at the natural domain. The natural domain of a given rule is the set of real numbers with which the rule makes sense. Take for example, if f of x equals x cubed minus 1, then the domain of f, or we call a natural domain of f, we call it d sub f here, will be all the real number x. X is any real number. This is because you can take any real number and raise to the power 3 minus 1 and it makes sense. Let's look at another example. G of x equal to 1 over x minus 1 times x plus 3. Then the domain of G, or we call the natural domain of G, we like d sub G, will be all the number x such that x not equal to 1 or x not equal to minus 3. Why is this so? This is because we know that we can put in any value of x and it makes sense, provided the denominator not equal to 0. So we know that denominator equal to 0 is equal to 0 when x minus 1 equal to 0 or x plus 3 equal to 0. So that means x equal to 1 or x equal to minus 3. So that means that as long as x not equal to 1 or x not equal to minus 3, then you substitute the value of x into the formula, into the rule, it will make sense. So this set of number where x not equal to 1 and or x not equal to minus 3 is all the real number. If you draw the number line, you'll find that this number, all the real number except minus 3 and 1. So we can write this set as minus infinity to minus 3 union minus 3 to 1 union 1 to infinity, where the whole real number line exclude the point minus 3 and 1. Let's look at an example. If h of x equal to 1 over x squared plus 1, then the natural domain of h, we call it d sub h now, will be all the x here, such that 1 over x squared plus 1 makes sense. But x squared plus 1 is never equal to 0, no matter what value of x you put in. So x can be any number. This is because there is no danger of dividing by 0 now. So this is the whole real number line, or natural domain of h. Let's continue to find the domain of function. Let's say f of x equal to x over x minus 2 squared. Since we have a quotient, so we must have x minus 2 squared cannot equal to 0, right? Otherwise, it will be divided by 0. So as long as x minus 2 squared not equal to 0, this is the same as x minus 2 not equal to 0. And this is the same as all the real number x not equal to 2. So as long as x not equal to 2, you substitute value of x, you'll find that the computation will make sense. The natural domain of f is all the real number except 2. So you can say this is real number line, where this is the point number 2 here. The point 2 is excluded, so it's from minus infinity to 2 union 2 to infinity in the interval notation. Let's look at another one. G of x equal to square root of x squared minus 4. I want to find the natural domain of G. Since we know when you take a square root, we must have x squared minus 4 must be greater than or equal to 0 before you can take a square root, because you cannot take a square root of negative number, as you cannot, right, take square root of negative number. Because of this restriction, x squared minus 4 must be greater than or equal to 0 before the rule makes sense. Okay? So x squared minus 4 must be greater than 0 for the rule to make sense. Must be x squared must be greater than or equal to 4. Now, if a number x squared greater than or equal to 4, there are only two possibilities. That means x must be greater than 2, so that x squared is greater than or equal to 4, or x less than or equal to minus 2, so that the square will be greater than or equal to 4. So this is the set of number. There are two key points, 2 and minus 2. So I must have the number greater than 2 or equal to 2 or less than or equal to minus 2. So in terms of interval, you can write them as a union of interval from minus infinity to minus 2, union including minus 2, union for interval from 2 to infinity. This is how we find the domain of G. Now let's look at another one. Suppose f of x equal to x squared minus 4 over x minus 2. Then the natural domain of f here will be all the x such that the rule makes sense. Now this rule will make sense, and notice that this rule will make sense provided the denominator is not equal to 0. So that means x minus 2 cannot equal to 0. Otherwise, you'll be dividing by 0. That means that this is all the real number x here, x not equal to 2. So if you look at the number line, there's 0.2 there. So x not equal to 2 means the number could be from minus infinity to 2, union 2 to infinity, excluding the 0.2. However, these domains are called natural domain. Now, sometimes function may come with a restricted domain. It means actually it's a smaller domain of a natural domain. For example, if f of x equals x squared, then we know x can be any number because you can square any number. However, you can also make a restriction, say x between minus 1 and 1. So this is a restricted domain. Whereas the natural domain of f in this case is equal to all the real number. Let's try to find the range of the function now. We know that function consists of rule, domain, and range. And the range will be collection of all the image of a value assigned from a point in the domain. So how do we find the range of the function? First one, suppose f of x equals x squared, where x using the natural domain of f is equal to all the real number, since any number you can square it. Now we know that for any real number, x squared is always greater than or equal to 0. So since y equal fx equal x squared is always greater than or equal to 0 for all x, so the range of f, we call it Rf here, the range of f will be the collection of all the y now, where y is x squared. Now we know that since x squared always greater than or equal to 0. So you collection all the y greater than or equal to 0. So this is the interval including 0 to infinity. Let's look at another example. Find the range of y equal to gx, where g of x equal to 2 plus square root of x minus 1. In this case, the domain of g is the collection of all the x here such that the rule makes sense. In order for the rule to make sense, we know that we cannot take square root of negative number. That means x minus 1 must be greater than or equal to 0. Otherwise, you cannot take square root. That means domain of g, the natural domain of g will be all the x here such that x greater than or equal to 1, which is the interval including 1 to infinity. How about the range of g? How can we find the answer? So this is the collection of y here, where y is equal to 2 plus square root of x minus 1. But we know that since square root of x minus 1 is a number greater than or equal to 0, so 2 plus square root of x minus 1, when you add 2 both sides, will be greater than or equal to 2. So y equal to 2 plus square root of x minus 1 will be greater than or equal to 2. So the range of g now, it consists of y here, y greater than or equal to 2. So this is the interval from 2 to infinity including 2. That will be the range of g. Let's look at another example. Find the range of y equal to h of x, where h of x equal to x plus 1 over x minus 1. So let's look at the domain of h first. Domain of h, which is the natural domain of h here, will be all the x here. Since we know we cannot divide by 0, so in order for the rule to make sense, x minus 1 cannot equal to 0. That means the domain of h will be x not equal to 1. That means all the real number excluding 1. This is from minus infinity to 1 union 1 to infinity, excluding 1. Now how to find the range of h now? Let's say y equal to x plus 1, x minus 1. Then the range of h will be collection of all the y. Now let's modify a little bit here. So y equal x plus 1 over x minus 1 is the same as x minus 1 plus 2 over x minus 1, which is equal to 1 plus 2 over x minus 1. And since we know that 2 over x minus 1 never equal to 0, because no matter how you do, you never get this equal to 0. Therefore, 1, if x, this is not going to be equal to 1. Therefore, the range of h now will be collection of all the y now, where y is equal to x plus 1 over x minus 1. And you find that this expression, x plus 1 over x minus 1, is always not equal to 1. So again, the range of y will be all the real number except 1. So this is a real number line. Consider a real number line excluding the point 1. This is from minus infinity to 1 union 1 to infinity. That will be the range of h.